Okay, so we cut off on example 6 here in lesson 2.5, finding our last two roots. If I do a quick recap, it was an x to the fourth, so there were going to be 4 zeros. They gave me 1, which was 1 minus 2i, which means we automatically knew there was also the conjugate 1 plus 2i. So we need 2 to begin with. We started by testing 1 minus 2i. It was a little bit of a chore, right? We had lots of foiling to do. But the good news was we got the remainder. So then we used that new line of numbers and our 1 plus 2i. And we checked that. It was not nearly as much work. Remainder of 0. And then we were looking at the remaining pieces. 4x squared plus 8x plus 13. Set it equal to 0 and solve. Okay? In an ideal world, we could factor it. But based on the fact that we know these are imaginary solutions, because remember we looked and nothing crossed the x-axis, we have to do our quadratic formula. So, this is what I had set up. What was it? As the bell was ringing yesterday in class, I think. Okay, so recap. Negative b, so negative 8, plus or minus square root of b squared minus 4ac. So 8 squared minus 4 times 13, all over 2a, so 2 times 4. That quadratic formula sound familiar? You should know it at this point. Okay, some of you just need to know. Let's do some cleanup and see what happens here. Negative 8 plus or minus square root. Okay, I know 8 squared is 64. What's 4 times 13? 208. So if we do 64 minus 208, what's 64 minus 208? Negative 144. All over 2 times 4, which is 8. Okay. Negative 8 plus or minus. What's the square root of negative 144? 12i, right? Because the square root of 144 is 12. The square root of a negative is I. So negative 8 plus or minus 12i all over 8. Because I'm trying to give zeros here. Zeros that I'm going to have to use in factors. I do not want to leave it all as one fraction. I want to put it in two parts, kind of like how we have the 1 plus 2i and 1 minus 2i. So negative 8 over 8 is negative 1. I'm going to go ahead and leave the plus or minus right now. 12i over 8. What does 12i over 8 reduce to? 3 over 2 and an I. 12 eighths is 3 halves, and then we have an I, so I'm going to write it as 3 halves I. Okay. We now have 4 zeros, correct? The directions said find the remaining zeros. Check that. And write f of x in its linear factorization. So, I'm going to write it in two different ways, because I want you to see it in two different ways. First of all, I mentioned yesterday on this particular problem that you always have to consider, was there a given a value? Was there a given a value on this one? Yes? What was my given a value? A was 4. If there's an a value, other than 1 obviously, you have to write it out front of your factors, because that is my leading coefficient. And the only way to carry down that leading coefficient is to just carry it down by hand. Now, parentheses. You should have 4 parentheses, right? Let's go with the ones we were given first. 1 minus 2i. So that's going to be written as x what? Minus 1 plus 2i. Remember how we were changing those signs? Next parenthesis. Let's use the 1 plus 2i. So that's going to be x minus 1 minus 2i. The next two are this negative 1 plus 3 halves I and negative 1 minus 3 halves I. So if we worry about negative 1 plus 3 halves I, it's going to be x plus 1 minus 3 halves I. And then if we use the negative 1 minus 3 halves I, x plus 1 plus 3 halves I. This is one way to express your answer. However, this is probably not what you'd see in the answer key. With that being said, I honestly don't see a huge problem with this answer. Okay. What the answer key will do, though, is they will look at, we have a couple of fractions in there. Is there a way we can rewrite it so it's equivalent, and yet I don't have the fractions? And there is, because what do we have out front? We have a 4, yes? And if you look, we have a denominator of 2 here and a denominator of 2 here. 4 can split into 2 times 2, yes? And you can multiply, we could take this 4 and multiply it into any factor. Or if we split 4 into 2 times 2, you can multiply it into any factors. And so the idea here is that this 4 can come down here and be split into 2 and 2 and be multiplied into the factors that have the fractions in. Okay? I'm not saying this previous answer is wrong. What I'm trying to help you understand is equivalent answers here. And that is a big part of math. Okay, being able to understand, okay, they gave this, I gave this, is it equivalent? So if I rewrite this, where am I going to rewrite it? I'm not sure. F of x equals, first of all, my 4 now is going to be gone because I'm going to multiply it into those other 2 factors. So I'm not going to write my 4. My first 2 factors, are they changing? No. It would be helpful if I blow this up at this point. So I'm going to keep x minus 1 plus 2i. I'm going to keep x minus 1 minus 2i. Okay. That third factor, multiply that factor by 2. That means you're multiplying everything by 2 in it, yes? What does that become? Mm-hmm. 2x plus 2 minus 3i. So 2x plus 2 minus 3i. Same thing with the last factor. Multiply it by 2. So if we multiply that by 2, it becomes 2x plus 2 plus 3i. This is an equivalent answer. Again, I'm flexible. Okay. I honestly would probably accept both unless there's some restriction in the directions that I can't, that doesn't allow me to. But again, knowing those equivalent answers. In AP, that's a big thing I stress because when you get to AP Calculus, half of your AP Calculus exam is multiple choice. You come up with an answer one way, they have it listed a different way. You have to be able to realize that those are equivalent answers. And so we can even talk about things like SAT or other math tests where being able to recognize equivalent answers is important there. So, okay. Let me stop this, and then let's see how homework went. Unless, did you guys have questions there?